I'll focus on the basic screening, but before I do that, I also want to quickly introduce you to the tool itself. So the Climate Adaptation Service or screening tool is available online, as you can see here, and it allows for an EU-wide automatic screening of climate risks. To enable an automatic screening, it's necessary to have a robust and standardized methodology. And the methodology that was applied here was based on EU guidelines and was updated to also comply with the 5th assessment report of the IPCC. So now we have this workflow that you can see here, which consists of 7 steps. So first one has to characterize the hazards that affect the area in question that one's looking at. In the second step, one has to analyze who or what might be affected by the hazard and where are these elements at risk located. Then it's necessary to identify or to investigate how susceptible these elements at risk are. And all these steps are necessary really to perform a risk assessment or impact assessment. And the last 3 steps of this workflow, they comprise the identification, evaluation, and implementation of adaptation options. So the Clarity Climate Information System now guides the user through all these steps, and it provides an easy access to publicly available climate data, use data, and information about adaptation measures. And as mentioned before, it's possible to perform a basic and advanced screening. For both screening options, there are the climate indices and additional data sets that you can see here. So these are land use data sets or digital elevation models that are available on Copernicus. So your imperviousness layers or Korean land cover or also Urban Atlas layers. And in addition, there are also 13 Clarity high resolution land cover layers, which were produced within the Clarity project by combining openly available data sets, the European Settlement Map, the Urban Atlas, and the street tree layers. And the advantage of these high resolution layers can be seen here maybe, because here we can see the airport in Linz or just outside of Linz. And in Urban Atlas, this whole region would just be classified as airport. And now with this layers here, it's possible to identify small buildings and to see where there's paved areas and where there's just grassland, for example. So these layers help exploring the area one is interested in. And if I now go to the basic screening, and here the first step, for the hazard characterization, we have the climate indices available for 1 historical period and 3 future time periods, and for the 3 climate change scenarios. And what you can see here is that the resolution that is available here, it's 12 times 12 kilometer. Well, it's too low to resolve urban structures, and thus too low to account for the urban heat island effect or to account for the variation in temperature, which is caused by small-scale urban features. But what one can see here is that the climate will change by quite a bit. Here I've taken the number of hot days for the historical period and for a future time period, and there will be an increase. Now it's possible to kind of make an overlay of the different data sets that are available in the system to estimate where the temperatures will be even higher due to this urban heat island effect. And for this here, just as an example, I took again the hot days for the historical period and the imperviousness layer that's available on Copernicus. And if one overlays these two, you can see kind of where Linz is and where the paved area is, and so also where it will be even hotter during the day, at least because of the absorption of energy. It's also possible to take other layers to investigate this, like the dense urban fabric or industrial layers, kind of the buildings that we've extracted. And here you see as well, it's again the Linz, and these areas will be even hotter, probably also during the night, because the long wave radiation will be trapped in urban canyons. It's also possible to make an overlay of these data sets to analyze the exposure. And for this, one has to kind of have a look at the additional layers again that are available and which ones one could use as a proxy for population in this case, if we want to have a look at heat. And so here I've again taken for the hazard layer the hot days, and then we'll show you here the urban fabric layers, and here only the buildings that are located in the dense urban fabric, median urban fabric, and urban fabric. So here are those buildings where people live. And if you overlay them, that's how it would look like. It's also possible to take other layers that are available on the Copernicus website, like the land uptake per person. And here just one has to be careful that the darker color illustrates the areas where less people are. Okay, and here it's obvious, here is where people live, so they will be affected by heat. And the screening tool also enables us to see how it all will evolve in the future. So now we have the static information regarding imperviousness and buildings, okay, that one has to keep in mind, but it's still possible with this to see where will the heat be more extreme and how will it evolve from the past to the future, and where are the elements at risk, in this case the people, are located. So if it's if it's hot here or in Linz, mainly these areas are kind of affected because here are the people that have to deal with the excess heat. So what is available as well in the system is a list of adaptation options, which can help the user to have a look at different options and to assess the costs and possible co-benefits as well. And we also have the twins opportunity. Here,
now,
again.
What Claudia is showing till now is mainly really data. The climate indices which were calculated and the land cover indices which we inherited and in some cases improved. That's nice. That's a good thing to have if you are like Claudia, an expert who can understand what that means. But frankly, it's not very easy, not very tangible for people who are not. And this is where so-called twins come in. These are examples of events which happened in the past, of projects which were already planned or already exist, also of future predictions with explanations. And if we are talking about Clarity Online tool, the point of that tool is mainly to be able to prepare a report. And so this kind of information can be added in a report together with the kind of information which Claudia was showing, which makes the whole report, let's say, easier to read and easier to understand. If I have a message to say, I can add some examples so people who are not experts, they will understand it better. So to summarize what we have from this simple screening, Claudia?
Yeah, so it's mainly a qualitative risk assessment. So we have the opportunity to have a look at the hazard at a low resolution, but still it tells us something. We can investigate exposure using maybe proxy data. And like this can estimate where the critical areas in our region of interest are. There's also a list of adaptation options, which we can have a look at in order to evaluate which ones might be of interest for us or for the user. And there are additional information where we can learn from other projects.